So thanks, Cory, for coming along. I really do appreciate it. Cory's one of our mentors for the Fall 2020 Fellowship. I think you'll be working primarily on Python projects, but if you do have any issues, you can have a chat with Cory. I'm sure he'll be more than happy to help. Today, Cory's going to be talking a little bit about using Git in the command line, which some of you may not have done much before, kind of going through how to do like pool merging workflows, rebase-centric stuff, forks, multiple remotes, all of these kind of things that you like can make Git very powerful that you may not have touched before. So without further ado, I am going to let Cory take it away and show us what he's got to show.
Hi all, nice meeting you. For those of you I don't know, so I'm Cory, as Will mentioned. I was a mentor with MLH over the summer, and one thing I noticed was that a lot of questions I received revolved around how to use Git, even for people who had experience using it. And there were basically two kinds of problems. Problems that arose because somebody had not used Git, and problems that arose because somebody had only used Git from within an IDE. So a lot of you might have, Git integrated with VS Code or something like that. And I think that is fine to use. In fact, if anybody tells you that the tools you're using are not fine, you probably should run away from that person. Generally, work environments that insist on particular tools are not good places. So I won't tell anybody, don't use Git within your IDE. I will tell people, though, that it's very easy to let things like that become a crutch. Because when you use Git, invariably something goes wrong. When you use Git in your IDE, things go wrong a little more often. And when something has gone wrong and you don't know how to use the CLI, you're kind of stuck. So this talk is for these two classes of people who simply have not used Git, and people who are more used to an IDE workflow. I probably won't teach you any real wizardry with Git because I myself am not a Git wizard. But this is going to be a good amount of Git to get you to the point where you have a sane workflow for the course of this fall. I have a repository here. This is just one of my repositories. I was messing around with stuff. Why did I choose it? Because it's small and easy to clone. Over here, we have a fork. So a fork is just another repository that has some ability to track the upstream version of it. If you want to make a fork, you just do this. I've already forked it, so as you can see. But now I have a fork over here in MLH. This fork knows whether it's up to date with the master branch of the upstream repository, and it is easy for me to make a pull request that will keep it up to date. But otherwise, these are separate. Forking is used for a lot of different purposes. Some people fork because there's a repository they like that isn't being maintained. For MLH, we kind of use these forks because that is also a very sane workflow to create a fork, create your branches, do all your work inside of it, and then only send along to the upstream repository a pull request that contains changes you want. Mostly this is done for maintainer sanity. Maintainers don't want you making a lot of branches on their repo because then they encounter a lot of noise. And you can imagine in open source land, which is kind of the Wild West, there will be a lot of noise if everybody's just allowed to make branches everywhere. So this is the workflow we settled on within MLH. So I'll get a little bit more to like how we're going to use these two forks in a moment. But first, let's just start doing things on the command line. So one thing I might want to do is actually get the code, right? So we've got all this kind of, I've actually never used this before. I usually use SSH. If you use HTTPS, that's fine. Don't worry about it. But I'm going to use SSH. I'm going to go over here to my terminal, and I'm going to git clone this. I have a, yeah. So it is so new. I had never seen it before. Like So I have not cloned a repository for like, I don't know, a month or something. So I guess that's how new it is. So we're gonna clone. Here we go. I have to enter my password. Okay, so now we have it. And you can see I have poetry bed. Yeah. And I can go into poetry bed and I can see how it's doing. I'm on the master branch, fine. So to get us well set up, the other thing I'm going to want to do is also add this fork. This fork is where I'm going to be making my branches. So the way I do that is same thing. I'm gonna download gonna copy this, and I'm gonna do git remote add. So oh, I need the name. We'll say MLH, whatever. So one thing about Git, you are never going to get the incantations right the first time. I mean, eventually you will. I never do. Can I magnify the font? Can I magnify the font? Yeah. Oh, yes. Okay, I can do it. It's garish, but is it more visible? Okay, Proficiency is good. All right. Oh. All right. So now just so we get a we now have two remotes. You'll notice that when you clone a repository, you automatically get a remote that is named origin by default. And then when you add another remote, you give it a name. You can also, again, you can rename remotes, you can remove them, you can do whatever you want. There's a help command. We don't need to go over all of that right now. Remote is pretty straightforward, but basically we now have my local version of the repository, and then we have two remotes, the origin and the MLH fork. So what am I going to do? I want to make a change. So let's see what we've got. I just want to make a small change. Here's my README. This is extra paragraph. So I've made a change. So if I want to make that work, actually end up somewhere, the best way to do that is to do it on a branch. The way I can do that is, let's just call this, so I'm on this branch example. You'll notice that I made the change before I made the branch, but Git saved my life. Git has a concept of unstaged changes. Those are not attached to a branch. And in fact, Git won't let me do certain things until I have stashed or staged all of those changes. So we'll talk about what that means in a moment. But point is, my current state is this. I'm on a branch. A branch is rooted on work that already exists. So currently this branch is up to date with master. That might change as the master branch gets updated. But that is what I can do is do some work and then try to later push that work into the base repository. So what I have right now is just, you can think of it as a copy, but it's got this one diff. And you can even see what the diff is from inside the command line. So there's git diff. By default will just show you the unstaged changes you have, but I can force it to look at everything on my current branch and diff against a particular other branch. In this case, the branch origin/master. Remember, origin is a remote and master is a branch. So I can diff against other remotes if I want. Can I do that? Oh, right. MLH fork doesn't have a master branch. Anyway, point is, if there were another branch on MLH fork, we could do that. So what else do I want to show you? So let's fix this change. Let's make sure that this change actually exists within the branch. So I'm going to do a commit. And there are two ways you can do this. Every commit has a message associated with it, as you might know. By default, if I just do this, I'm going to go into my my operating system's text editor. Oh, sorry, something I have to do first. I have to add my change. And now I can do a commit. So this commit brings me into my my text editor, which by default I have set to Vim. But there's another way I can do it. You'll notice if I don't add a commit message, Git gets really angry and won't let me commit. The other thing I can do instead is just specify the message here. This is a very uninformative commit message. Your commit messages should always be informative, but we're not actually doing anything interesting, so it's hard for this commit message to be informative. So let's look at our status again. Nothing to commit, working tree clean. That means that there are no unstaged changes. So every change is now sitting in this branch. It is affixed to the branch, and I can now do whatever I want. I can go to another branch if I want. I can do anything. So let's actually make another branch. So you'll notice I now have 3 local branches. They are the 2 I made and master. You get master by master I got when I cloned the original repository, because master is by default the branch that you are going to clone. Some repositories have branches that have different names, so there might be idiosyncrasies, but in general, master is a terminology used for the branch that that kind of commands all other branches. You may remember there was a kerfuffle about this a few months ago. They're trying to change the name of master, but they haven't got around to it yet. Anyway, point is, we're now on a different branch. We can also find out what upstreams branches are tracking. I'm not going to mess with that right now. I'm just going to show you how to set an upstream branch so we don't get too confused. Point is, these are local branches. So it's not really useful if my branches are just sitting here on my machine. My branches also need to somehow talk to another branch. Let's go back to our example branch. And I'm going to I think this is the right syntax. Yes, there we go. Remember how I said earlier you're never going to get the syntax right? I mess this up like every time. Sometimes there's a slash, sometimes there's not. So in this case, I do set upstream. I could also have done -u. MLH fork, that is my remote, and then example2. It's generally, so what I just did was I made my local branch track the remote branch. And what that means is that those 2 branches are now kind of bound together and can interact with each other. So if I look over here, I should now have a branch. There we go. Called example2. You notice it wasn't there before I refreshed. So now I have this branch and I can look at it, and I can, if I want, I can see that same diff that I saw in the command line. This is something you might be familiar with if you've ever made a pull request. I'm not going to actually make this pull request, but I just wanted to show you this is what happens when you set upstream, when you do this push. So let me just, I realize I've kind of just gone through a workflow and thrown a lot at everybody so far. So let me take this opportunity to see if there are any questions. So far, all we've done is get some things off of a GitHub repository, make some changes, make some branches. We saw how to add things, stage things for commit. We saw how to make a commit, and then we saw how to make sure that that shows up on GitHub. Does anybody have any like sources of confusion at the moment? Upstream. Oh yeah, I'm being a little, I think I was a little concise with that. When you set upstream, you specify which remote you are going to associate that branch with. So when I do git push set upstream or git push u, what I'm saying is, I want you, so actually let's back up a bit. We haven't gone over pulling and pushing, but pushing is when I take my changes and put them on another branch. When I set upstream, I specify the particular remote that I want to associate that with. So I could also, for example, do, if I wanted these changes on that other remote. But the upstream is basically the remote that is the remote that has a branch that is associated with your local branch. Does that clear it up? Yeah, so Devin asked a good question. Is there a convention when you should commit your changes and how to structure them? I find myself doing a ton of work and then just adding and committing it all. That is, yeah, that is a question that lots of people in the software industry have a lot of opinions about, but it's very tricky in practice to make sane commits until you just have experience with it. So the ideal, I'm not saying that one will ever necessarily achieve this, even like 50% of the time. The ideal is that each commit makes an atomic change, and that everything kind of works, or at least is like syntactically correct after that commit. So the ideal thing would be like, let's say I'm adding a feature, right? Let's say I'm adding, I've got some server. Yeah, I mean, so that is a good point. Gagan, sorry if I'm mispronouncing your name. It is definitely subjective, but broadly, there's a thing that people would really like to see is like, I'm adding a feature. Maybe I add one commit that's like a deactivated test for that, for some feature, right? It's like, all right, I've got a server and I want to add a new endpoint that accepts a certain thing, right? So maybe the first thing I do is I add a deactivated test. And then like in another commit, I add like the first version of the code to see if it's working. And then in another commit, I like, expand on it. But at every point, I've got something that can run. I've got something that is syntactically correct. And then, at the very end, maybe I like activate my test and make sure it's running. And then I have like these 4 very, very nice commits. That will never happen in practice. In practice, you're going to do a lot of work. You're going to like mess around and go, does this work? Hopefully your commits are not completely random. Hopefully you don't have like half of a variable name somewhere when you commit. But yes, generally people ask for small, sane, functional commits. I hope that was enough of an answer. Okay, good. I'm glad that kind of answers the question. But yeah, as was mentioned, it's pretty subjective. What else? Okay. Cool. So let's kind of go on to the second part of this. So the second part of this is really about what do I do? What happens when multiple people are working on the same repository? Because frankly, that's the only reason we even do this. I mean, there are other benefits of version control, but in general, if you're working alone, you don't have much to worry about. So let's look at our status again. We've got branch example, and it's got this change, right? So here's what I'm going to do. I'm going to go to my my origin branch. I'm doing it from the origin branch because I am very sorry. Yeah, this is what I wanted. So you'll notice when I make a pull request, by default, here is the repository that I have set as the upstream for the branch. It's calling it the head repository. Here is the base repository. So by default, GitHub does the right thing. It wants to make a pull request against this origin. So the reason that you do that is that one of the really common uses of a fork, as I've mentioned, is just to kind of reduce noise and clutter for the maintainers. So nobody can see over here my example branch. And that's good, right? Because if you think about what the open source world looks like, you've got like maybe hundreds of contributors, right? And like some of those people are just jokers. Like they're just kind of messing around. You don't know what they're doing. They're not necessarily doing useful work, and you don't want to see all of their branches. If they make a pull request, they're kind of serious about it, right? So that is the only time when you start to see something. So here we go. I have my making my pull request. By default, this subject is populated with the last commit message, where I can say like, really good example, I'm good, or just whatever, or just we can go like surrealist with it, just like trunk. All right, we're gonna make this pull request. Now, because I'm switching hats. I am no longer a contributor, I'm a maintainer. I come over here and I look and I see, oh, somebody wants to merge this pull request. Well, okay, good. It looks real good. I love it. Really into this commit. It's a very good changed file. Normally, this would be the time when I actually don't do that and I actually complain a lot and tell you that your code doesn't work, or that you are breaking my continuous integration. Fortunately, not set up on this repository, so we don't have to wait for it. This would be the time when we would have an actual discussion about the code and see whether it's doing what you claim it does. But in this case, I'm a very lax maintainer. I'm just going to merge this pull request. Okay. So now we're on example 2. Oh, I actually made a mistake. Let's see. Sorry about this. I actually made a mistake. Oh, so we're good. Cool. So, actually, we need to do all of this. So this is now up to date with the master branch, the local master branch. So what you'll notice is that I don't have that extra line in there. And we can see this when we go like this. So git fetch is a very important command. Git fetch is how you incorporate all the most recent changes from your remotes into your local clone. So now you'll notice that this branch is behind. It lacks that line. There's nothing to commit, but we can see that there's a diff, right? So here I'm going to do something. Let's say that I had been working simultaneously. I hadn't paid attention to what this other person was doing. And I'm adding this paragraph here. Or keep doing that. So now I've got this, my version. And you can see that there's a little conflict here, right? So I've eliminated, this is an extra paragraph, which is what exists at master. And I've added my paragraph is very good, which is on my branch only. So if I tried to make a pull request right now, so I've pushed, so now I'm going to try to, go here and make a pull request. And you'll notice it says can't automatically merge. And the reason is because of something called a merge conflict. So you've all probably dealt with this before. The basic problem is this. We have a branch, it does some work. We have another branch, it does some work. Sometimes those two kinds of work are orthogonal, so there aren't any conflicts, but often that is not the case. And so what you have to do is incorporate all the most recent changes and then resolve these conflicts. There are two strategies. So there are two things I need to do here, first of all. My current branch, example 3, does not know about this most recent change in the sense that this file only has this one change. It's only added, my paragraph is very good. The diff tool knows that something else is going on, but I've never had both of these changes in the file at once and kind of made a decision about how those two should interact. So there are two ways to resolve this, and they are, I have a preference for one. Basically, different repositories have different preferences. The first, the one that I like less, is pull. So, and by default, it's going to pull origin master. And then I've pulled in the changes, and now I merge. Oh, that's weird. Should give me a conflict. Let me look at this. Oh, I see. Right. So I meant to pull this. So when I do that, now I've got a merge conflict. Here's what a merge conflict looks like. I I see head. Head is my what I'm looking at right now. Head is on my branch. This over here is the commit hash of origin master. So yeah, so some people really love using VS Code for this, and that makes sense. I know that it is like a lot easier in certain kinds of IDEs, but again, one day your IDE is going to barf on you, and you're going to be really happy that you know that you know what's going on under the hood. So really, what I want is just to have both of these like that. So I've resolved it, and now here we go. So now you'll notice I was in a merge. When I pulled in origin master, I was in doing this merge. So what I need to do is I need to then commit. So Git is very helpful when you're in the middle of a merge. Currently, I was trying to merge because I pulled in the origin master. Now I've added this file to indicate that I have resolved the conflict. And then I can just say, and then I'm going to push. I don't have to specify upstream. It already knows what my upstream is. But now when I go over here, it can merge. Everything works. The other kind of workflow, and I'm not going to necessarily demo it because we're running out of time, is rebase. But I'll just show you what it looks like. So and then I'm going to do a rebase. This gets us to the same state. We have this merge conflict. I have to do the same thing. Notice I only have the one paragraph because I didn't actually merge the other pull request. But point is, we end up in the same situation. Git rebase, continue. So you might ask, like, what's the difference? Because at the end of the day, we have the same thing, right? Here's example 4 where I did this this rebase, and here's example 3 where I did a pull and a pull. So you might ask what the difference is. So the difference is how Git stores changes and how it applies those changes. So here's like master branch. Here is my branch. In my work branch, I've made some changes. Now, the two ways I can resolve these things, according to Git, are a pull or a rebase. A pull says take everything in master that I don't have over here and just apply it. So take all of these diffs and add it to this set of diffs and just smush them together. So what that does is it preserves all of the commits from both branches. And that's really nice for people who really, really care about like the commit history having exactly the same hashes. But it's also really confusing because what it does is it kind of doesn't preserve a logical ordering. So even though like this is the master branch and it's been chugging along, it kind of treats these commits like they all kind of were happening simultaneously, which is what they were doing, but it makes the commit history a little weird. This other thing, rebase, is much easier to reason about, because what it does is instead of taking your changes and applying them at the point where you branched, it kind of goes, all right, let's pretend you made your branch up here, right where master is right now. So when I rebase, I take my current branch, I replay everything that happened since the last time I diverged from the master branch, and then I replay all of my changes on top of it. So it looks more like, you know, there's this master branch and then there are my changes, and it's this kind of much more logical separation. It makes things a lot easier at merge time sometimes because you're not dealing with like these simultaneous histories. Yeah, so Kishore, you got it right. It's one set of changes on top of another instead of seeing everything kind of intertwined. A lot of the maintainers that I'm working with, particularly this fall, prefer rebase. And in general, that is the direction in which people have gone. So that said, yeah, I'm open for questions now. What are the advantages of keeping things in staging? Sometimes I need to stash when I need to go back to another branch real quick, then come back, rather than that staging is just a step before committing. I mean, yeah, I personally, again, as I said, I am not a Git wizard. So I personally have never found a good reason for things just to be staged, right? But staging is useful simply because if there weren't a staging area, we wouldn't be able to atomize commits, right? So I'm not sure that there's like any real trickery you can do with like keeping things staged. But I am sure that like there are times when I have a bunch of stuff sitting there and I don't necessarily want to commit it all. So this actually goes back to the other question you asked, which is like, how do you make a good commit? So like sometimes I've had to change like 10 files to understand what's going on. But at the end of that process, while all those 10 files might need to be changed eventually, I can actually look back and see that like, oh, there were several logically separable components to this process I underwent, right? This messy holistic, interdependent process can actually be broken down. So then the staging area is really just a place where you like pick and choose files to commit from and break them into more atomic commits. But yeah, I've never like felt like stash really saved my butt or anything. What else? Any other questions? And again, as I said, I'm not a Git wizard. All I wanted to do with this was make sure that people understand how to use these commands and just have a sense that, it's not that hard. Mostly because I have noticed that when we get really reliant on IDEs, there is occasionally a kind of mysticism or magical thinking around how Git works. So I'm hoping that this has at least shown you that, you can use the command line. It's not too onerous. And if you're using your IDE and it has Git integration and you have some kind of problem, you now have a backup plan. Otherwise, thank you all.
Awesome. Well, thank you so much, Cory. Really do appreciate it. Looks like we have one more question. Do maintainers prefer squash merge over rebase/regular merge nowadays?
So generally what I've seen is maintainers want you, not everybody. Some maintainers have like, okay, let me back up a bit. Some maintainers really like pull and merge based workflows because it preserves those commit hashes. So there is like a level of Git wizardry that I only dip into when I really have to, and I don't understand it that well, but it involves like, having a lot of understanding of the different commit hashes, moving to different commits and cherry picking them and stuff like that. So from what I understand, pull is really useful for that. So some maintainers prefer that. But by and large, what I have seen is that the clarity and ease of reasoning that comes with rebase is much preferred. So maintainers prefer that. When it comes to squashing, again, this kind of circles back to Devin's question. As you're working, you're going to make a bunch of just extraneous commits and some inane commits. Maintainers don't want to see that in their repository. So what they really like is an interactive rebase where you pick some commits and squash other commits, so that what you end up having at the end of the day is like only 3 of your commits or something will show up.
Wonderful. Well, thank you so much, Cory, for coming along. For those of you who are new to the fellowship, we'll be running these sessions regularly with different speakers. If you do have any suggestions for things, let me know. I sent out an email for content that you might like, and I can try and sort something out. But just want to wrap things up there. Thank you, Cory, for coming on. Really do appreciate it. I think you said you wanted to run a couple more in a few weeks or something, so you may see Cory reappear with a few different topics. Wonderful. I'll hopefully see some of you at another session in the next coming days. Right. Thanks, everyone.